Okay, maximum power transfer theorem. Maximum power transfer theorem. What is maximum power transfer theorem? Suppose there is a source in the electrical network and one sink or load. Then load will consume power along with the internal resistances or configuration of the circuit. So how can we say a load will extract maximum power from the source? Means that is the maximum power that a source can supply to a particular load with its internal configurations. So suppose there is a network. This is a network having one voltage source and number of resistances which may be considered as its internal configuration, and suppose this one is the load resistance RL and these resistors are named R1, R2, R3, R4, and this is the voltage, supply voltage Vs. Then suppose the current flowing through the load is IL, that is load current. Then from this load current, the power supplied to the load will be PL equals to IL square RL. Means current flowing through, square of the current flowing through the load and the load resistance. Now when this power will be maximum, how we will calculate? We will calculate by varying this load resistance. We will try different resistances. Suppose 1 ohm to 10 ohm, we will vary load resistance from 1 ohm to 10 ohm. Then at a particular time or particular value of the resistance, the load resistance will be maximum. And more than that resistance, the power will be lower, and less than that particular value of the resistance, the power will be lower. So only at a particular resistance, the power consumed by the load will be maximum. How we will find out? To find out, first we will convert this circuit to a Thevenin circuit. Suppose we will convert this circuit to a Thevenin circuit. This circuit contains one voltage source in series with a resistance, and that combination is parallel with the load resistance. And the current flowing through the resistance is IA. Then what are the values of Thevenin resistance and what is the value of Thevenin voltage? Thevenin voltage is the voltage drop across this load resistance when the load resistance is open circuit. That is, it is the open circuit voltage across the load resistance. Similarly, RTH is the Thevenin's resistance is the internal resistance of the circuit. How will we calculate the internal resistances? Internal resistances can be calculated by opening the load resistance along with the sources removed. Means the voltage sources are converted to short circuit, and if present any current source, then we will replace it as an open circuit. From this, the equivalent resistance is calculated from the load resistance side, and the voltage source is calculated as the open circuit voltage across the load resistance. From this circuit, we can find out the power will be PL equals to IL square RL, where IL can be calculated as VTH divided by RL plus RTH. Then the power will be PL equals to IL square RL equals to VTH square by RL plus RTH square into RL. Then for a for any value to be its peak value, that is for maximum and minimum value, the values, the differentiation of the value with respect to the variant will be 0. That is differentiation PL by differentiation RL should be equal to 0. From this mathematical formulation, we can find out RL should be equal to RTH, which also can be taken as internal resistance RL. If only this condition, the power to the load will be, power supplied to the load will be maximum. And the when RL equals to RTH, we can write IL equals to VTH divided by 2 RL, or VTH equals to 2 RTH. Then power will be PL equals to VTH square by 4 RL into RL, that will be equals to VTH square by 4 RL. It is the maximum power that can be consumed in a load consisting of number of internal resistances, and where the value of RL equals to the internal resistance of the circuit or Thevenin circuit.